By the end of this century, traditional farming as we know it will likely be impossible in many regions. Grazing herds will be replaced by meat and dairy grown from harvested cells in a bioreactor. Native wildlife will struggle, and invasive species will thrive. To control destructive pests carrying disease, scientists will rely on aggressive, lab-engineered gene editing just to keep their populations in check. Outside the labs, ecosystems that once required long intervals between natural burns will face a constant global onslaught of extreme fire weather. These peer-reviewed projections from ecologists map exactly what Earth looks like if global temperatures reach 4 degrees Celsius above pre-industrial levels. This highly synthesized, heavily adapted existence is what researchers now consider more likely than not to become our reality, assuming current warming trends persist. For decades, the public understanding of climate change was that it would be a slow creep. The expectation was a gradual, manageable shift spanning multiple generations. The data no longer supports that timeline. We are locked into an abrupt, accelerating trajectory where a 4-degree world is our default destination. This sharp pivot didn't happen yesterday. The acceleration actually began in the background just over a decade ago. To understand exactly how our timeline compressed so rapidly, we have to examine a specific anomaly buried deep within the climate data from 2013 and 2014. Looking back at those years, climate researchers reviewed 5 major global temperature datasets. They were trying to figure out why the Earth was heating so erratically. The problem with tracking global heating is that Earth's temperature naturally fluctuates. Massive volcanic eruptions pump aerosols into the atmosphere, causing temporary cooling. The sun goes through cyclical phases, bombarding the planet with varying levels of solar radiation that pull temperatures up and down. This thermal map shows the El Niño pattern in the Pacific Ocean, which unleashes chaotic bursts of heat. To find the true trend, scientists applied a noise reduction method. They took these natural factors, volcanoes, the sun, ocean currents, and stripped them entirely out of the climate record. Without the natural static, the pure human-driven warming signal was left isolated on the page. By mathematically removing nature's chaos, the data proved that human activity was heating the planet significantly faster than our baseline models had mapped out. Between 1970 and 2015, the Earth was heating at a steady rate of less than 0.2 degrees Celsius per decade. But starting in the last 10 years, that rate nearly doubled. The velocity of global heating spiked to about 0.35 degrees Celsius per decade. International leaders had established 1.5 degrees Celsius as the global safety threshold, the absolute limit for avoiding severe climate breakdown. At our current velocity, we are on track to cross that 1.5-degree limit before 2030, with some data models showing a breach as early as 2028. We are already seeing the physical manifestation of this speed from above. Regional environments are buckling under intense heat waves and aggressive fire weather. The crisis is a matter of velocity. This current rate of acceleration outpaces the planet's physical ability to adapt. This rapid heating is compounding because our natural defense systems are starting to fail. The planet's carbon sinks, the forests and oceans that historically absorbed our CO2, are struggling to keep up with the volume of pollution. At the same time, we've successfully reduced certain industrial emissions, like cooling sulfur pollutants. But paradoxically, this has stripped away a temporary atmospheric heat shield, driving temperatures even higher. Pushing past 1.5 to 2 degrees Celsius triggers a cascade of irreversible tipping points across global ice and ocean systems. With natural planetary defenses collapsing at the exact same time our heating accelerates, humanity will be forced into those artificial, highly synthesized survival methods required for a 2100 reality. The 4-degree world isn't an absolute certainty yet. The window to avoid it is closing rapidly, but it is not completely shut. To alter this velocity, researchers calculate that global fossil fuel use must be cut entirely in half by the year 2035. And to stabilize the atmosphere long-term, humanity must reach absolute zero fossil fuel emissions by 2070 at the latest. We are developing the technologies to adapt and mitigate our emissions, but the pure math shows that the planet is currently heating far faster than we are changing.